谢今天大家来参加GCPUG今天的活动。那今天活动有请到那个嘉威，然后伊恩，然后还有一位 Google 的讲师，他们也要过来。那今天活动其实主要是要介绍这个月的主题会比较 focus 在 Big Data 跟 Learning 的部分。那我们会尽量找这方面的 speaker， 然后来分享他们的经验给大家知道。那等一下的场子，我们等一下会有一些活动，有声音大家先关一下，让我听到声音。好 ，OK。那今天的那个活动原则上有做过 Handout Live， 然后就是之后大家是可以上那个 YouTube 看。Okay， 那今天场地很高兴，就是很感谢 MyTech 可以制作我们今天的场地。那我们请 MyTech 这边的主管跟大家说句话，这样子。
不要打扰大家时间，我就是反正出现过很多次了吧，大概谁不知道我。Anyway， 我们这边MyTech 会继续sponsor GCPUG 的所有的活动，然后我们也是要找更适合的场地，比如说有时候要过夜啊，凌晨的时候我们要找一些更好的场地，可以继续把那个 GCPUG 搞大一点。然后我们GCPUG就是我们后面也会延伸到香港啊其他地区，就是我们希望把我们这个粉丝团越搞越大，大概这样子。然后带回来的 Google 啦，会有一位是从美国来的，他们的 Technical Director， 他会昨天他其实在 Google 也讲了一场，待会在同样会讲一次很漂亮的 slide， 会把整个 Google 的针对那个好度就是 data pool 的部分讲得很 detail， 然后待会大家好好听一下他们的那个简报然后待会就先请谁开始？
请嘉威。
嘉威就先开始我们这个活动然后饮料入壳的话，大家可以先在外面拿饮料，但是不能拿进来，所以说你们可以签个名放外面，不好意思。然后不然就是 break 的时候到外面拿饮料都可以 ，OK？
那我们先请嘉威，先自我介绍一下。
这样子有听得清楚吗？那谢谢。就是今天就是感谢3位就是邀请我，然后来这边跟大家分享。然后我是嘉威，然后是那个台湾User Group 目前的那个义工，就是我在帮忙排一些议程这样子。那就是先简单，虽然在这个场合介绍自己社群也怪怪的。那就是我们社群就是每个礼拜一，然后也都有在办活动这样子。那主要都是跟 data、跟资料分析好、跟machine learning有相关的。那如果大家有兴趣的话，是可以在我们的 Facebook 或者是 Meetup 上面，然后看到我们的活动。那最近几个活动可能是跟 Spark， 因为我们就是伟创的人，然后来跟我们分享，说要来分享一下我们在 Spark 上面的经验，就是属于教学的。那所以大家如果有兴趣，也可以来参加这样子。好，那我们就简单讲到这里。那就是今天呢，我主要是想要跟大家分享那个BigQuery 的话，就是因为在我们公司里面，我直接讲，就是我是露天拍卖的那个工程师，然后我们公司现在也是开始慢慢把资料放到 Google Cloud 上面去，主要是跟交易资料有相关的。那可是就是大家在开始用 BigQuery 这些服务之前，那高层主管就会很 care 说我们的资料，尤其是跟客户交易，他买了什么东西，这种东西就是怎么能够放心的就把它放到外面去了这样子。那所以我们那时候也挣扎很久，然后我们就开始去寻找路。大概从去年的6月开到现在已经快1年了。那我们从那个时候开始在找相关 有没有什么可以在加密的状态之下，然后做计算这样子。那后来我们就找到了一篇论文，叫做 Encrypt.DB 这样子。然后你在搜寻的时候，你加个 MIT 比较好，是麻省理工那边的一篇，然后你应该会找到他们的官网，他们的网站。这个，那他们就是有办法，这个东西就有办法做到说，就是我把资料然后加密以后，然后放到外面的 DB， 然后在那个 DB 上面，然后就是你可以做 sum 啊、goodbye 啊，然后 sort 那些相关的运算这样子。那大概速度大概还可以保持在大概70%左右，就是你虽然做很多加密的东西，但速度大概就降30%这样。那主要的论文是上面这一篇2011年的，那就是你如果打开看的话，就论文内容大概是像这样子啊，那没有什么很复杂的公式，它是把他们的那个架构跟你讲完这样子，像这样的架构。那有兴趣的你可以直接看。那因为今天只有30分钟，所以我就直接跟大家介绍怎么操作，这样最快。那在这个东西上面呢，一开始我们是看，然后我们就往下看，看到发现说，哎，怎么 Google 也有，而且还是 BigQuery 这样子。那然后微软啊，然后就是一些 SAP 这个，就是他们也都有用的话，我们一开始也是蛮怀疑说这东西到底可不可以用，后来就发现这些公司好像有做，那就是应该稍微有点保障这样子。那既然这个东西有的话，那 Encrypt BigQuery 的话，如果你去查的话，你应该会看到他们的 GitHub 上面有一个这个，但是这他们完全就没有 focus 在这个专案上面，它只是写，而且里面还都是纯Python，就很慢这样子，就它还挺慢的。但是如果有兴趣，你可以看着它上面的 tutorial， 那你就可以去照着操作一下这样子。比如说一开始你照它上面就是那个创造他们的假资料，然后会放去 BigQuery 上面，然后你就可以开始在上面做一些操作，比如说把 data 弄上去啊这样子。那有兴趣入门的话，就是可以先从这个专案开始。那我们一开始也是先从这个专案这边开始玩，因为想说人家 Google 都已经写，那我试试看怎么可以这样。那可是一用下去之后，就发现，哎，我们只是加密了50万笔资料，它可能跑1个小时这样子，就太久。我们每天都至少要上传100-200万笔以上资料上去，那个速度慢到不得了，所以我们就在里面研究它的 code 是怎么写的。然后把里面的资料拆，比如说他用 Python 对不对？然后最一开始我就把它改成 Python 这样子，我就直接把它改写，然后大概速度快上20倍这样子。那然后再顺便做个平行化，然后大家才可以应付我每天的需求。那后来就是 Python， 然后后来再慢慢改成比如说再改成用 Java， 然后就改成 Spark 下去跑这样子。那我们目前公司内部就是每天大概会上传蛮多笔资料上去 BigQuery。那然后在上面直接运算，然后不败后结果再拉回来。那所以有兴趣可以先从这边开始。那我直接介绍那个它里面的一些细节，就是如果你想做的话，大家可以像这样做。如果你有兴趣的话，你可以先来这里，然后我昨天才刚刚，因为我前2天简单写了一下，就是一些简单的操作这样子。这是我的账号，那你可以在上面找到，然后你可以这边有看到一个 IPYNB， 你就把它点下去。然后我今天就直接介绍这份里面的内容，所以操作都会在这里。有兴趣的话可以上来看一下。然后啊，就是在这个 EDQ 里面，主要用到3个加密演算法。第一个叫做 AES， 这个大家应该都很常看到过，就是你有在做加密的应该都会看过。那第二个叫做Pair 的演算法，这个。然后第3个叫做 OPE， 它是那个 Order Preserved Encryption 的缩写，就是这个就是有办法 Pair 这个演算法，就是有办法让你做到 就是明明是加密过后，比如说你要做那个5+10，那5先加密，那10再加密，那加密过后2个在做这个奇怪的运算后，然后解密化就是15这样子，黑猎可以做这件事情。那 OPE 就是 Order Preserve， 它就是可以让你做 Solve 这样子。那这3套Python 是都有工具，那你在 Java 上也可以找到。就是你如果用 Python 觉得很慢，你可以直接把它用 Java， 你可以去用 Java， 你知道 GitHub 上面有很多有人写完的。那 AES 的话你就是直接去装这个套件嘛，这应该大家有用过，应该很熟。然后 K 的是 GitHub 上面去搜一下也会有，然后 PYOP 也会有，你简单去 Google 一下就好，就会找到这3个工具。那所以说这3个工具的话，那我们比如说先简单看一个配列这样子。就是今天这个的话，主要是让大家可以简单的知道这些演算法大概在做什么，那原理就不去管它，所以就是直接抓下来。那你这个把它装下去的话，那你可以简单看到它上面的一些介绍，就是比如说它要做2+3，对不对？所以加密过后是 x 跟 y， 然后用它这个方式，然后出来是 x y 原本是2跟3加密过后长这样子。那这2个再经过它那个 pair 的 a 了之后，然后出来不是这样，那最后再解密化就是5，这样知道怎么操作就好。那再来像开那个 OP 的话 ，Order Preserve 那个的话，你也可以直接搜一下那个。你应该会找到这个工具。这个套件，那它其实也是很简单的一件事情，就是它大概原理就是，比如说你要先确定好你的数字的范围，比如说它这边就是先确定好说你要加密的数字大概在-100到100之间，那它可能会帮你那个 random 投射到，比如说它这边是0到9999之间这样，比如说1可能帮你投射到98，那2就会投射到107什么的，就一定要比98还要大这样。那有一个 random， 那让人家不容易回推回去这样子。所以你看它这一边的话，就是比如说它去2000，然后加密过1000加密、2000加密、3000加密后，那去测是不是一定这样子顺序是不是1000一定小于2000小于3000这样，那最后出来会是 true 这样子。那所以说，只要把这2套演算法知道怎么用，然后把它融进去一颗里面的话，那就可以开始实做那个加密相关的东西了。那比如说像这样子，一开始先把一些那个要的套件把它搂进来，这样你只要这几个套件都有装好的话，你就是可以开始玩这个 IPIMD 档。所以先把套件搂进来，然后刚才说有3套演算法，一个是 AES， 一个是 Pair， 那一个是 OPE 这样子。那我只是为了等它方便，所以我先把它弄成 class 这样子。那这个有兴趣你就自己直接照着做。那所以先把它们都先开出来一下。那最一开始的话，就是比如说我先弄一份假资料这样子，假资料只有几笔，4笔而已。那4笔先把它弄进去，然后把它读出来以后。我这上面很有执行，就是我现在就是去指定说，因为刚才我要弄进来这个资料啊，它是这样子，它有几个 column 啊？3、6、8，它有8个 column。那每一个 column 我都要决定说它要用哪一种加密演算法。那比如说我现在只是要做跟 group by 或相加有关，像 Python 它就是数值，所以它很适合用在相加上面，所以这个就会用刚才 Pair 来做。那我可能想要根据 inverse price 来做 solve 的话，那这个 column 这个栏位就要用 OP 来对它做加密这样。那所以我现在资料读进来了，对不对？那接下来我是开始每一栏，我就是要去对它做加密的话，那我刚才 making 里面我有指定说这个 column 我要用 AES 来做加密，那 price 我要用 Pair 来做加密。 那 invoice pass 我用 OP 来做加密，那把它们对应的那个加密的方式把它对应起来一下，就是为了大家方便理解，所以我就先这样写。那你就是也可以照着做。那所以它这样子的话，我现在这个是对每一个 row 就一个 row 一个 row， 然后读进去，那然后看它们对应的栏位是用哪个演算法，那就对它做加密这样。所以说原本是这样子嘛，现在 row data 长这样，那我把它丢进去每个 row 做加密的话，出来后就会长这样子。那就经过加密好。那加密的话就是，那一般到时候要上去 BigQuery 的时候，这些 year 啊、map 这些原本它可能都会改成 C00、C01这样子，让大家辨识快出来这个 column 什么。那我们放在 BigQuery 上面 data 是像这样子。那所以像刚才这样，那解密的话也是一样。我刚才解密的话，这里又有写好对应的，就是 AES 的话就是用这个方式来做解密这样子。所以这样就有办法再解密回来。那我们接下来就可以开始来玩一下一些有趣的事情了。那比如说这个 year 和 string， 就是这个 schema， 就是如果你有用过 BigQuery 的话，你应该知道那个 BQ 在 load 的时候，就是 BigQuery 它有给你 command line tools， 然后你 load 的时候最后面要加一个 schema， 就是你每一个 column， 然后第一个 column 名字叫做 year， 然后我要让它上去的时候就是 string。然后它是一定是需要这个值的这样子，所以 schema 先把它写好写进去，然后我们就可以开始把它丢进去 BigQuery 上面了。我现在先丢那个明文的上去，这个 counts 就是明文的这一份，然后它现在就是这一行，它就会把这个资料放上去 BigQuery 上面。running， 然后等它一下，然后结束了，然后这时候应该就可以在 BigQuery 上面看到它了，这样。等一下，我要切换一个账号。
上面那个等于最上面的工具列的切。
是哦，
多
把
上面在上面系统的多把。
系统的拖把左上方。哦，好。然后刚才的卡就会在这里，它现在就上来，就是刚才那4笔。那然后接下来上去了以后，那我们就是也可以就直接对它做 query 的这样子。比如说现在有什么都不做 ，query 这样就可以直接 query 一下。那所以当然我也可以直接把它读进来，然后就在这里面就可以开始直接做一些运算都可以。那反正接下来，那我们就开始丢一份加密过后的上去吧，就是加密过后的这一份了。那一样把它弄过来一下，那把它丢上去 BigQuery 上。然后这时候应该就可以看到刚才 encrypt 这一份也已经上来了，它已经4个栏位，那值都是加密过的。那这个的话是用 OP， 等一下我要用它来做 sort 这样子。那比如说刚才这一份是 encrypt 的，刚才大家已经看到这一份 table 是加密过的。那我刚才这个 我现在想要用它来做 sort 这样子，所以也就可以直接用它做 order by， 就算它即使它现在在加密的状态底下，所以我现在让它去 query 它这样子，然后 query 是像这样，所以你可以去它丢回来给你的是乱码，对不对？哎，就是加密过后结果。那我就先把它读回来这边，然后再来看一下，确定它现在都还是乱码。那我们把它解密开来一下，你就会看我刚才说 invoice price， 然后由大到小做 sort， 你就会看到的确是有做过 sort 的这样子。那接下来的话就是再看一下怎么样做 Payly 的那个 group by 的sum，就是在加密状态之下做 sum。那这个的话就是因为 Payly 它有演算法，就是你要运算的时候，你要把你的 public key 一样丢上去给它，在 BigQuery 上面。那它的 public key 的话就讲起来有点复杂了，我觉得大家可以先照着操作这样。总之就是你上去那个 Payly 的 sum 啊，就是 BigQuery 它其实它有做在他们里面，但是它文件上都没有写。我们一开始知道这个的，我们一开始会知道 BigQuery 背后这个可以用，是我们刚才有一个 GitHub 的那个project，他们 include 的 BigQuery， 我们在里面看到了，所以就直接拿来用这样子。那所以你现在你要对它做那个 Payly 上的话，我用 Payly 然后送 price， 所以等一下我会用 make 来对他们做 group by， 然后上这个 price 这样子。那它里面我就是要注意的事情就是，它上的时候用 BigQuery 里面 Payly 上，然后我去上这个 price。那你要在加密对它做那个上的话，你要把你的公钥给它。那公钥就是刚才我在这里处理过后这一串，它其实就是因为你 BigQuery 上面它只吃那个 base 64编码的，所以你一开始你要先把它转成 bytes 以后，就原本它是一个很大的数字。它原本是一个很大的数字，两个质数的相乘这种数字这样，然后再给 square。那这样说这应该是非常非常大，那只是我这边为了速度方便，我就是先把它缩很小，要不然原本这个可能会长到几十位数，大概这么长以上这样子，让大家不好破解。那所以这边的话就是原本的 long， 然后把它转成 bytes， 然后再变成 base 64出来就是长这个base 64，然后没有 base 64，所以直接 long to bytes 的话 bytes 长这样，然后把它丢进来。那现在让它去做 group by， 我用 make 做 group by， 然后再对 price 做上，所以说应该会有这个跟这个相加起来应该会9900，那再来一个4799跟3000这样子，那就来验证一下，就是你让它直接去做。它现在在跑运算，那再把它读回来，的确变成3笔这样。那目前都还是加密状，那你再把它解密化就会搞定了这样子。就是刚才说的9900，一个4799，一个3000，这样。所以说就是用3套加密演算法，就是可以应付你基本上公司如果说你们的资料，然后怕说上去有问题，要先经过加密再运算，可以用这种方式。那这个速度的话，在我们公司内部测的话，就是我们是改成 Python 跟 Java 在测。那大概我们每天会上传大概快，我只能说100万笔以上的资料这样子。那大概都会在30分钟以内加密完，然后就直接上去。那就是说我们公司的需求是说那个。因为我们有些交易的分数啊，那可能要连续追溯到过去60天份。那60天份在我们公司可能都反正上千万笔，然后每天或每个小时可能就会跑一轮。那就是自己在公司顾 DB 才顾的有点烦，那就是放上去。那上面不败算完之后，就是那数量就缩小了嘛，然后拉缓，然后再写进自己的 DB， 然后才在自己 DB 再另外做处理这样子。所以大概会像我们公司大概目前用的方式像这样。那我看时间也差不多，如果有问题可以问，那如果没有就介绍到这里。
问一下，目前这样资料啊，它其实加密过后，其实那个资料应该是变大。
对。
有算过说你们这样子的
会扩大将近快10倍。
10倍。
对。
所以你们应该有 有做很多 optimize 才能够。
就是比如说先，因为它虽然它扩大10倍，可是你再把它踏完或什么，要再压回去，又变小了。
我只是说，如果你放到database 里面，它本来一个数字是10，然后你扩大10倍之后，它变成10个位，那你在摄取的时候，因为 BigQuery 它是否你查多少资料量来算费用，
对，
那这一块就会变，费用上就会变多。对。
就是我们反正主管那边考量说好像也没有问题，就是还负担得来嘛。是啊，
算便宜吗？
就是至少我们用起来觉得还 OK 这样子。我们已经这样 run 蛮久了。
久，真的，因为GCPUG好像是我们2年前看到的。
对，是啊，
他如果有一个，他还不是BigQuery旧，他就是说他要旧，他里面用了感觉用了18，然后所以他分成加密进去。
对。那其实我们重点只是在说，我们有一份运算，然后就是要往回追溯几十天这样子。那在我们公司目前第一可能有一点就是蛮吃力，那就是放上去算这样子，就不再买机器了这样。
你有考虑过用那个？它不是有出那个什么方选，在 SQL 里面可以放。EQ 可以被一段 JS， 那叫什么？预设顶的方选。那一段如果可以写加密，我不知道会引用到加密。
它那个会有麻烦，因为它现在的 BigQuery UDF 方是每个 row 这样处理，它没有办法，因为你要做上必须要直的这样子，column 这样上，那它没办法做。对，那或者有一个方法，就用 data proc， 然后上面开 Spark， 然后用那个 Spark SQL 的 UDF， 那倒是可以做。我们也有测这个，方法。
我只是说，如果在上面做引扣这件事情，自己写算法，有没有比较划算？不知道。
可是你说引扣就是在上面做那个加密嘛，对不对？可是 data 一定是你放上去加密，就原始资料就已经上去了。
加密完成，
一定要在本机这边先加密完成再上去。
一定要有前面先处理这
对。
所以他们讲用 data proc Spark， 加密完成，然后。
还有其他人有问题吗？目前我不知道大家有用过 BigQuery 吗？不用指，你们都有用过，我知道。OK， 其实 BigQuery 它是 Google 一套蛮特别的一个服务。如果有机会的话，可以玩玩看，因为 BigQuery 是让所有就是不懂所谓的大资料人，我可以直接用 SQL， 我就可以查好几 terabyte 的资料。然后那个时间范围是可以接受，不用查个6个小时、7个小时，下班。一般你送出去查询，大概1分钟内都会回应。那只要你的 SQL 没有太大的问题，大概6秒钟就回应。那这是几 terabyte 的资料去做处理，而且它可以做 database 的9年，所以蛮多情况下用这个东西可以减少很多负担。好，那看大家有没有问题。如果没有问题的话，我看一下时间，等一下。OK， 那如果没有问题的话，我们就请Ian 这边，然后跟我们分享下一个 section。那外面有饮料，那如果你要用饮料的话，可能要在外面稍微就是饮用，然后再进来。对，饮料不要拿进来。
对，写个字，
一口气拿进来。好，那我们感谢嘉威跟我们做这个分享。 在他准备的时间，我先介绍一下。Ian 是 Google Japan 这边的 Double K， 所谓的 Double K 就是很像传教士这样的角色。那原则上他会了解所有 Google Cloud 的服务，而且会有一些很特别的实作。那像这次他有在 Google I/O 上面有一些展示，就是有关于 IoT 跟 Data Flow 后面这些东西的串联，然后做了一些还不错的那个就是 demo。那我刚好问过他 YouTube 上面有自己还没看，所以我觉得大家回去可以摄取一下Ian，然后在 YouTube 上面找一下他的那个 session， 然后看一下他做的那些，应该蛮有趣的。那今天他会跟大家带来的是有关于整个 GCP 在这个今年度到现在的一个 update 的状况。OK， 那我们欢迎Ian跟我们介绍这个，谢谢。
Everybody, I'm glad to be back in Taiwan to join the GCPUG event. It's good to see all of you guys again, especially Simon. So Simon kind of introduced me, but I'm just to introduce myself again. I'm Ian Lewis. I'm the developer advocate for Google Cloud Platform in Tokyo, Japan. So that means I kind of work with developers to make it easy for people to use Google Cloud Platform by giving talks and educating people, and finding out from developers what sort of things about Google Cloud Platform are not good, and kind of giving feedback to developers inside Google and things like that. But today I wanted to give kind of an update on Google Cloud Platform and kind of talk about the sort of new releases that have come out in the last year or so, and talk about some of the new releases that were announced this year at our major events, the Google Next and Google I/O. Let's get started. So so there's basically been a lot of stuff being released in the last year. I won't even be able to really cover all of it. These are just a few of the things that were released in the last year, some of the major things. But I'll try to touch on the kind of ones that I think are really major and big, important releases and updates. So the first ones that I want to talk about are in the kind of compute area. So like Google Cloud Platform has a lot of different services, and they're kind of roughly grouped into areas like this, like compute, networking, big data, management, storage, machine learning, and developer tools. So things that make developers' lives easier. But first I want to talk about the compute and specifically compute engine and container engine. So compute engine is the virtual machine service. So you can basically make Linux or Windows servers. I think most of you are familiar with this type of service. But some of the important things that came out as part of GCE in the last year were one that's really important is custom instance types. So this is allows you to kind of create a very specific type of instance that has the right type of CPU or right amount of CPU and memory for your specific workload. So you can actually, if I jump out here and jump into the console, it's kind of easy to show off this little feature. So if you go into the console, click on Compute Engine, and then create a new instance. So this will create a new VM or a new server. So Asia, because I like my stuff to be close. And you can kind of, there's this machine type section here where you can pick the type of server that you want. So this, you can pick from the drop down here, which gives you 8 CPUs and 30 gigabytes of memory. And there's like a bunch of options here. But you can also click this customize button here. And that allows you to pick the exact number of cores and the exact amount of memory that you want for your instance type. So you can, if you don't need very much CPU, you can kind of lower the CPU and raise up the memory, or you can add a lot of CPU and not very much memory. It's also kind of like a little bit within limits. So if you have a lot of CPU, you still need a minimum of a certain amount of memory, but you can kind of still kind of customize what type of machine you want to have. So this is really important for folks that have different, have needs that are like very specific, or they wanted to reduce the amount of cost for the service that they want. Another important addition is the changing the size of the volume without downtime. So this means you can attach disks to a VM, and those disks have a certain amount of size. So you can pick like 100 gigabytes or 10 gigabytes or whatever you pick. But now you can actually update the size of that disk, and then when you run a command within the operating system to kind of update the size of the disk, you can upload or update the size of the disk without actually stopping any of your services. So the OS can upgrade the size of the disk, and you can actually make the size of the disk bigger when it starts getting filled up. You have maybe a database or whatever, and so when you need more size, you can just extend that. You don't have to create a new volume and copy it or do something strange like that. So that's a really convenient thing, and you can actually script that and do that automatically. Like if you're running out of memory, or running out of space on the disk, you could automatically run a script in a cron job to make it bigger. Those type of things are now possible. So that's a really, really cool feature. There's also persistent disks can now be up to like 64 terabytes, which not very many people need 64 terabytes, but some people do, I suppose. And also preemptible instances are a really cool type of instance that are kind of temporary. So these are used for things like batch jobs and things like that. So they have a maximum life of 24 hours, and they can be shut down at any time based on the use within the data center. But they cost about 1/3 of the normal cost for a VM. So these are very good for things like batch jobs or things that you can have kind of varying capacity with your workloads. And this was announced as GA, which means that it can now be used for production workloads. We also, this wasn't in the last year, but it was released a couple of years ago, but Kubernetes is a new open source project from Google it's a kind of a manager or an orchestrator for Docker containers, or for containers in general. This is, it's inspired by Google's experiences inside of running our production services, because all of our services run inside of containers. And so at Google, we start about 1 billion or 2 billion containers a week or so. We have a system called Borg that's very much like Kubernetes. And so we wanted to create an open source project based on our knowledge of those type of systems, so that other people can start to build systems like that. And so recently we released Kubernetes 1.2. 1.3 alpha is actually was released like yesterday or something. But the newest stable release, which was released a month or two ago, was Kubernetes 1.2. And this was a really big release that added a bunch of speed and stability improvements to Kubernetes, as well as introduced some new features like deployments. Deployments are kind of a way of creating an application or an object for an application that then can manage the containers and then do things very easily, like do rolling updates and scaling up and down of a containerized application. We also added Ingress, which is used for load balancers. So you can create an Ingress object and that will create a load balancer for you. We also have config maps, which are a new type of objects for creating configuration files and for containers, as well as a new dashboard UI and pod autoscaler, so you can autoscale an application within your cluster. So this horizontal pod autoscaler can work with the deployment, so you can create a deployment and then autoscale that deployment, so that based on how much CPU it's using, you can start up new instances of the application or reduce the number that are running. We also have a hosted version of Kubernetes, so it's really easy to create a Kubernetes cluster using what we call a container engine, and this will start up and create a Kubernetes cluster using GCE, so using the compute engine, and this will manage all of the components of Kubernetes for you, so it's very convenient for doing that. And it also integrates with things like cloud logging and cloud monitoring so that you can more easily monitor your applications as well. And this was released to GA like last August, so almost a year ago. But we continually update it, so like whenever we release like new versions like 1.2 or 1.3, we typically are able to update container engine within a week or so. Another really important project is, or a new really important service is Cloud CDN. So CDN is a feature very much like, if you're familiar with App Engine, App Engine has a feature called a edge cache, which will allow you to cache some of the responses from your application in edge nodes that are very, very close to your users. So it's much like a CDN. And Google Cloud CDN is actually a service that works with, it's very much like that, but works with the HTTP load balancer inside Google Cloud. So this is actually really, really easy to use. So if you go into the console and go down here to networking, and you actually create a load balancer. You can create the HTTP load balancer here. If you say start configuration, and you actually start creating a backend service for the HTTP load balancer. All you have to do to enable CDN is just go down here and click this checkbox. So once you click that, this backend service is then enabled for CDN. So it's really easy to you can update this anytime you want to, and it's then the responses for that particular backend services are then cached in the CDN. You can also do things like invalidate certain parts of the cache. So like if you need to, if a certain piece of content was updated and you want to clear the cache, you can hit an API call and clear the cache. And you can also clear it by prefix. So if you want to clear like all the keys that start with a certain value, then you can just clear all of them in one API call, which is pretty convenient. So that's another one of the important services. So next I want to jump into big data, and in the next presentation, some of the guys from the data flow and data proc team are going to talk about these services, but I'll kind of go over them a little bit. But first I want to talk about BigQuery. So we had, in the previous presentation, we had got a little bit of information about BigQuery and how to do like kind of encrypted queries and stuff. And that's definitely one of the really cool features. But a couple of the ones that I wanted to talk about was the long-term storage pricing, which is new. So if you have a table in BigQuery, normally you can update those tables continuously, but if you have a table that you're not updating anymore, it's just static, then after 90 days that it hasn't been updated, it will be, fall automatically into long-term pricing, long-term storage pricing, which is half the price of the normal storage pricing. So if you have a bunch of tables that you're creating, that can the ones that don't get updated will actually start costing less in terms of the storage. So this is really good for things like logs that you create a new table every day or things like that. There's also the kind of query explain feature, which helps you a little bit in determining where a query is slow and how to help optimize the query. So I'll show like a screenshot after this, as well as user-defined functions. User-defined functions are pretty cool because what they allow you to do is write some JavaScript and use a JavaScript function as part of your BigQuery query. So here I can show you what that's like. So if I go to, here's one that I have that's a query with a user-defined function here. So when you're in a query, editing a query, you can click the UDF editor, and over here you can write some JavaScript to define a function that you can use inside of the query. So here I've created this URL decode function, and then in here what you do is you say define function, and you tell it like the name of the function and what sort of things you can, the output column names for the function, as well as some information about the output types. So here I'm going to say I'm going to return a title and a request, and the title is a string and the request is an integer. And then I give it the URL decode function that I defined up here. And then I return just a JavaScript object with the title and requests. So these two fields match the fields that I defined here. And then what I'm doing is I'm just calling this decode helper, and this decode helper just calls decode URI on the string. So what it's doing is taking a URL encoded string and then turning that into a Unicode string. So that's really good for parsing things like Chinese, where the URL gets encoded in a weird format that you can't really read. So here what I'm going to do is I'm going to select from this URL decode the return value from this URL decode. And I'm going to give the URL decode function another query that returns data from page views for Wikipedia. So I'm going to search for the Chinese Wikipedia and pull out all of the titles and the number of requests. But then I'm going to pass it to URL decode to decode the title strings so that I can actually read the title strings. So if I click that, I can actually run this with the URL decode function. And this actually doesn't really change how fast the query runs. The query still runs really fast. So I just processed 300 gigabytes of data in about 10 seconds, which is pretty normal. Or, it's about the same amount of time it would take without a UDF, so without a user-defined function. So you can kind of see like the most popular Wikipedia titles based on a particular string. Query explain is a kind of little UI that you can see after you've run a query that will tell you each stage of as the query was executed, and then where all the time was spent in the query, as well as how much input and output to each step there was. So this can kind of help you figure out why a query might be slow or things like that. So if I go back here, you can kind of request or response. You can click this explanation tab and then actually see the explanation of the different stages of the query. So I won't go into like these too much in detail, but you can kind of see the input and output sizes, as well as some of the details about what each one is doing. So next, I want to talk about data flow. So data flow is a kind of a stream batch processing service, which you can use to process a lot of data. This is kind of a replace for something like maybe MapReduce or other types of BigQuery or big data type of services. So what it allows you to do is do streaming processing of data or batch processing of data using the same type of, you can basically write the same exact code that you would for both, and then just change like a few parts from streaming to batch. So it's very simple kind of programming model. Normally what you would have to do if you wanted to go from streaming to batch, you would have to like use a completely different system. Like you would have MapReduce for batch, and then like Apache Spark or Apache some other streaming, like a Flink, streaming service. But Dataflow will allow you to do both with very similar code. Dataflow is also the API for Dataflow is also released as part of as Apache Beam. So it's kind of an open source project, and then there are runners that can run on things like Apache Flink or on other types of streaming services or batch services as well. So you can kind of you can either run it on Dataflow and Google Cloud, or you can run it on things like Apache Flink or Apache Spark. So there's not this kind of like vendor lock-in. You can kind of move things around. The features of each of the underlying systems are slightly different, but in general, the API or how you would write the code is the same. And then there's Dataproc. Dataproc is is very similar in that it's the same type of big data processing, but these are managed open source servers. So things like Hadoop, Spark, Pig, and Hive. These are basically when you start up a Dataproc cluster, it will start up a bunch of GCPUG which will then install the Hadoop and stuff like that on it, and allow you to basically start up and create a new cluster very quickly. So if you want to start up a Hadoop cluster and just play with it, you can do that, or you can start up a Hadoop cluster to run your batch job and then shut it down, every day or whatever. You don't have to keep it running all the time. So this is really nice because you can just like hit an API and create a cluster and just kind of run with it. So a lot of people really like this because setting up Hadoop clusters or Spark clusters is really hard and it's time consuming. So people like to be able to just hit a button and start it up. And yeah, this went GA just a couple of months ago. So now this is something that we think you can use for production workloads. So next, I want to talk about Cloud Bigtable. And Bigtable is a service that I really like. I did a talk here, I think, last year about Bigtable. But Bigtable is a service that came out in beta last May. We're working towards making that GA very soon. But what it is a service that's a NoSQL database that we provide that uses the same database called Bigtable, which we use for a lot of our services like search, analytics, maps, or Gmail. This is basically the database that allowed Google to scale to a very large size. We weren't able to use things like regular databases like MySQL or other types of SQL databases because we couldn't scale to a very large size. So we developed Bigtable about 10 years ago, and this is a very stable and fast database. And when we created it, we also released a white paper which explained what Bigtable is and how we created it. And then some people read that paper and created HBase, which is kind of an open source version of Bigtable. And so when we released Cloud Bigtable, we provided a HBase compatibility API, so it allows you to connect to Bigtable and use Bigtable just like you would HBase. So it's like just like a managed HBase server. But what actually makes this a lot different from HBase is that the size can be much, much bigger of the data, as well as reads and writes are both very, very fast. So if you run a GCE instance and you connect to a Bigtable cluster in the same zone, then you'll get latency for reads and writes that are less than 6 milliseconds. So this is quite fast compared to things like HBase or Cassandra or other types of NoSQL databases. So this is one of our partners or one of our customers that is working on a service or a solution to store all of the United States stock transaction information. So these guys ran tests using Bigtable, and they're using Bigtable as their backend database. And they were able to achieve at peak, they were able to achieve over about 56 million requests per second on Bigtable. So that means they were doing 34 million reads and 22 million writes at peak. So this is something that's like just very hard to even think about, these types of big numbers. But it's very, very, Bigtable can handle quite a lot of reads and writes at the same time. So that's the kind of big data type of solutions. But kind of what's really, really hot now, or what's really, really popular right now is machine learning and basically the things like machine learning or AI. And we're starting to, at Google, we're starting to release a lot of new kind of services and open source projects around machine learning. So you may know that this like Cloud Translate API and Prediction API have been around for a long time. So these are services that we kind of externalized from some machine learning projects we use that we created internally. But one that we released recently was this Cloud Vision API. So what these APIs are basically pre-trained models, machine learning models that you can use as using an API with just an API call. So you can just send some Chinese text to Cloud Translate API, and you'll get back maybe some unintelligible English. But the idea is that you can just give it some text, and it will give you the translation of it. And the prediction API basically allows you to predict whether something's spam or not, or things like that. And the Cloud Vision API is very similar. You just upload a picture, and it will tell you like where the faces are in the picture, or where or what sort of things are in the picture by giving you some labels. So the Vision API gives you a lot of, has a bunch of different features or different modes to it. So one is that it can classify images by tag. So you give it an image, and it can tell you that it's got cats in it, or it's got people in it, or it's got dancers, or bears, or whatever. It has quite a lot of tags. This is actually the Vision API, and the models behind it are actually what people use for what we use for Google Photos. So if you've ever seen Google Photos, let's actually look at my photos. Like you can just search in here for some, you know, random tags, and you'll be able to find it. So like statue. You know, if you enter in statue, you can like, you know, get back pictures of statues, or you know, what's another good one? You know, or if you put in like a place, you'll get back pictures of a place, right? Or it's another big tag, dogs. So like I didn't actually tag these with any. I didn't say this is a dog, a picture of a dog, right? It just knows that it's a picture of a dog based on the models that it uses in the Vision API in the background. So here, even if I search for dog, I get GCPUG.TW. But these are all pictures of my dog at home. So those are the types of like tags you can get back. So like you can get back that it's a dog, or like sometimes you can even get back what type of dog it is, which is pretty amazing. But you can also do things like detect faces, and it'll detect where the face is and give you the location of the face and where its eyes and the mouth are and things like that. You can also tell the sentiments, so whether the person's happy, whether they're sad, whether they're angry or not. You can also detect inappropriate content. So, like if people upload pictures of things you don't want on your website, then you can kind of detect whether it's inappropriate or not. I won't tell you what types of content that might be, but you can also do things like text detection. So if you take a picture of or if you have a picture of some text, you can actually get back the text that's in the picture. So you can detect the text and get back the actual text description. And you can also do things like landmarks and logo detection. So this is like a little demo. I don't know if you've seen this little bot, but this is kind of a Vision API bot, which takes pictures and then sends them to the Vision API. Let me see if I can find this video.
Cloud Vision provides powerful image analytics capabilities as easy-to-use APIs. It enables application developers to build the next generation of applications that can see and understand the content within the images. The service is built on powerful computer vision models that power several different services. The service enables developers to detect a broad set of entities within an image, from everyday objects to faces and product logos. The service is so easy to use. As one example of the use cases, you can have any Raspberry Pi robot like GoPiGo calling the Cloud Vision API directly. So the bot can send the images taken by its camera to the cloud and can get the analysis results in real time. It detects faces in the image along with the associated emotions. The Cloud Vision API is also able to detect entities within the image. Now, let's see how facial detection works. Cloud Vision detects faces on the picture and returns the positions of eyes, nose, and mouth. So, you can program the bot to follow the face. It also detects emotions such as joy, anger, surprise, and sorrow. So the bot can move towards smiley faces or avoid anger or surprise face. One of the very interesting features of Cloud Vision API is the entity detection. That means it detects any object you like. Let's see how it works.
It's glasses. It's banana. It's automobile. It's money.
It's new.
See? Cloud Vision lets developers to take advantage of Google's latest machine learning technologies quite easily. Please go to cloud.google.com/vision to learn more.
Yeah. So that's like a kind of a pretty fun little demo that one of my coworkers created. So you can like kind of create things like that, like kind of bots or these type of interactive things using the Vision API. So here's a kind of a demo that was shown at GCP Next, which is in March. This was part of the keynote that Jeff Dean did. So let's load this up actually. So this is like kind of a demo that shows a bunch of images kind of grouped together by their tag. By kind of genre. So over here you can see like sports pictures are kind of grouped together, as well as nature pictures or snow pictures. Over here is like transport. So if we go to like sports, these kind of, see if I can zoom in here. Kind of difficult. A little bit difficult with this. There we go. I can zoom into some of these. Should change the images. And I can kind of click on some of these images. So it'll let me. The Wi-Fi might be a little bit weird. Jump back out of. Reload this and see if it looks better. Okay. Like if you kind of zoom in on some of these pictures, you can kind of click on one as they pop up. And you can kind of get information about what the API sees as part of the image. So here it says like see, this maybe is like, it can pick up some kind of more vague types of ideas, like vacation, or an islet or a coast, the coast of the near the ocean, like villa. So these types of tags. So you can kind of get a lot of information about the picture through the labels. So these are some kind of demo ones over here. So if I click on this, this is like a good one that'll show like the types of things, like the fact that it's a cat, a pet, it's a mammal. And actually tell me like what type of cat it is. It's a British short hair. So it's also carnivorous, which is kind of funny. But you can also do things like get the text from an image. So I can show you kind of like what that's like. So here you can see that this like kangaroo crossing is on the sign here, and you can kind of get the text out of the API through the OCR detection. So this also has like really good labels like traffic sign, street sign. It actually picks out wildlife, which is interesting. So here's a good one that shows facial detection. So here you can see that it's like picking up that this is a social group, but you can also get the locations of all of the faces, as well as if you look really closely, you can see that they've got little points on their face near where the eyes are and where the mouth is, because you can get the location of the different pieces of their face from the API. You can also get back whether these people are happy or sad. So this person here, person 2, is very likely to be joy, like to be happy. You can kind of see that for each person. You can also get things like whether they're wearing headwear. So this person 6 has a little bow on their head. So it's kind of saying maybe they have some headwear on, like maybe they have like a hat on or something like that. So this is also, this next picture kind of shows the landmark detection. So this is actually based on the image, what's in the image, it can tell where that image is. So in this case, it's actually detecting that it's the Citi Field Stadium. And this is actually in, I think this is in San Francisco or something. No, where is it? No, this is New York. Yeah, so this is like the Citi Field Stadium in New York. So you can kind of tell, like, just based on the picture, where it is. Like, and you can actually see in here that it says Citi Field, but it's still pretty interesting that an API can kind of pick out like where something is just by the image. And then things like logos. This is a little bit of a cop-out, but picking the Android logo, but you can kind of get back whether something is a logo and what sort of brand it is or something like that based from the API. So, oops. So one of the other APIs that we're planning on releasing, we haven't opened this up to everybody yet, but we announced that we're going to do we're going to be releasing a cloud speech API. And what this does is basically does speech to text. So when you can basically send an audio file to this API, and then it will give back the text of what people said in that audio file. So you can either upload it in kind of batch mode, where you just send it in an audio file, and then it reads it and sends you back the text. Or there's there will be another API that's more real time, where you can send the audio in a streaming kind of format, and it will read the audio and then send back on a different channel what the text is that's actually being said on the audio. So that's very similar to the way that you can do like a search on your phone. When you click the microphone, you can talk into the phone, and then it kind of builds the query as you're speaking to it. So you can kind of do like things like dictation, or like dictating like a blog post, or like some text you want to write in a document or whatever. So that's basically what the speech API is. I think that the original, in the beginning, it's going to support English and Spanish and Japanese, I think. So that's kind of, I don't know if it's going to support Taiwanese or like Mandarin Chinese to begin with, but this is definitely something to kind of take a look at. So the next thing I wanted to talk about, which is also kind of machine learning related, is TensorFlow. So kind of like Kubernetes, TensorFlow is an open source project that we released that's based on work that we did in Google. So Kubernetes is kind of a rewrite or an open source version of the internal service called Borg, but that we used. But TensorFlow is actually basically the same library that we use at Google internally to do our machine learning tasks. So this is something that we're using now. This isn't something that we just released because it's old stuff and we've got a newer version that we like better or anything. This is like what actually Google uses for our production or for our services. So what it is basically it's a general purpose kind of machine learning library that is written in Python. It has a core that's written in C++ in order to make the machine learning tasks fast. But the code that the end user, the developer, has to write is all in Python, so it's very easy to read and understand and write. And once you've trained up some models using TensorFlow, you can then use those models on many different types of devices. So like you can even run some models on small devices like an Android device, like a phone. So we do that for some things like facial detection and stuff like that. You can also build kind of production services so that we think that, that machine learning should be used in production. So for things like to build services like Google Photos or other types of services like that that use machine learning, we think that people should be able to use that in their production systems, not just for research or in an academic kind of setting. So we kind of released a distributed version of TensorFlow, as well as a little library called TensorFlow Serve that allows you to take a model and then create a service or an internal server that you can then query to do things like classification and regression, machine learning type of tasks. So here's an example of what TensorFlow code looks like. So this is just a very simple example of creating a network or a neural network. Generally, right now, TensorFlow is generally geared towards building deep neural networks, but in the future, we hope to support like other types of machine learning tasks. But basically, what you can do here is like create these variables. These are things that get updated during the training, as well as placeholders, which are basically variables that you can input into the training task. So here we're basically just doing a very simple kind of matrix multiplication, and in addition to do some machine learning. So actually, if I go back here, so I also have I'm a fan of Jupyter, so run this for a second. But this is kind of a demo, and I'll be talking about this actually tomorrow at PyCon Taiwan. But this is kind of a little demo of some of this famous MNIST training set. So what MNIST is a bunch of handwritten numbers. So things like 1, 2, 3, 4, 5, like little handwritten numbers saved as images. And then you can train this particular model to read those images and then tell what number it is. So in this case, I'm going to just go ahead and run this. So this is just loading the test data. So here I've got 55,000 images. So this is 55,000 long, and then each of these images contains 784 pixels. It's a 228 by 28 image. So here's what a sample image looks like. Basically what you do is each of these are grayscale images, and they're represented as big arrays of 28 by 28 data. Or, 784, an array of size 784. And then, so here's like just a sample of one of the images. So this is just basically what one of the images looks like. And then when you do training, what you do is you give it an image, and then you give it the actual number that image is written on the image, and then the model or the neural network can then train based on that training data. So here we're giving it a vector or an array that's 10 long. So it's either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like one of those. And whichever one it is, like in the array position, it's going to have a 1, and all the rest will be zeros. So this is what one of them looks like. So this is this is an 8. So here, if we look in the 8th position, it'll be a 1, right? And then each of those values gets kind of combined into using the neural network to learn all of the, like, which pixels are likely to indicate a certain number. So here is a kind of a visualization of the neural network after it's trained. So you can kind of see that numbers that are or handwritten notes that have these pixels kind of filled in tend to be a 0. So this kind of makes sense because it kind of looks like a 0. So like anything that has pixels like in these areas will get weighted very highly as a 0. So this is a very simple like model, but it works like a decent amount of the time. But you can kind of see like in the different patterns like that each of them kind of sort of looks like the particular number. So this one looks like kind of like 6. This one kind of looks like a 7, etc. So here's actually where we're creating the neural network. So we're basically just building that and then creating a training step. So what this does is basically we'll take the neural network and then, or this is defining the neural network, and then the second part here is defining the function on how to train the neural network and say that this value is good, this value is bad. This basically is a type of loss function called cross entropy. But basically, what it does is says that like if you're very far from the right answer, then it will try to correct for that during the training. And so once I do that, like I can just train it by doing a batch of 1,000 times, or training it 1,000 times on many batches of data. And then you can kind of check the accuracy of the model at the end. So this is just 90% accurate, which is really bad. But this is a very simple, like one layer deep model. So you can build a much more complex model to get much higher accuracy. So the best models that you can create for MNIST data now, I think, are about 99.97% accurate or something like that. But what TensorFlow allows you to do is like build these kind of models, and then it will create the graph that's used to do the calculations, and then run that on very optimized C++, the C++ core. And because it builds all of the graph for how the data is processed, you can then create a lot of visualizations or use like these type of visualization tools. So as part of the graph, you could put in like little checkpoint or little positional things to output some debug data, and then show it inside of a tool like this. This is actually something called TensorBoard. I haven't actually gotten to setting up something like this yet, but these type of tools exist to help like kind of debugging of building new TensorFlow models. So let's jump out of here. So like TensorBoard will allow you to do things like show you the graph. Like if you just showed the graph of the previous example, it would look something very similar to this previous example, like very small. Would be a very small graph, but you can define like very complex graphs, and it'll show you like the different inputs and outputs of each section, and then it can show you kind of information about the loss functions, like how accurate your model is becoming as time goes on, as you train it more. So For certain models, like if you got it wrong, like then your model won't get very much better as you train it. But if you kind of create a good model, then it will, as you train it more and more, it will get more and more accurate. And then you can kind of see the accuracy as you train it more and more using these kind of visualization graphs. So a lot of people have been playing around with TensorFlow and it's quite powerful already. So like people are doing things like, giving it an image or just a picture of say like some buildings, as well as say like a piece of art like Starry Night, and having it like kind of merge those two and show you and create new art based on the image and the style of a particular piece of art. And then finally, TensorFlow is an open source project, and it will help you to like kind of run machine learning projects and train models and things like that. But in order to be able to do very deep kind of neural networks and train on lots of data, you need a lot of computing power, as well as the ability to scale that out to many, many machines to distribute that. Google has like built as part of our machine learning platforms and like our machine learning training models, a very, very good set of machines and networks that allow you to train very much quicker than you would be able to using kind of typical networks. One of the main things is not necessarily the number of like GPUs or the speed of each individual machine, but the ability to take a bunch of machines and then connect those over a really fast network and run them and run training on them. Typically, you can't really do that without scaling or scaling beyond a few nodes because the network becomes a bottleneck. But at Google, we've sort of built a lot of our data centers to have very fast interconnects between the machines to allow kind of these distributed training scenarios. And so we're going to be releasing cloud machine learning later this year. And what this is allows you to write TensorFlow models, basically write the TensorFlow code, and then be able to run the training of those models in a managed service. So you basically just write the TensorFlow code, and just like you would run it on your own machine, you can just say run it in the cloud, and it'll just run really much faster. That's essentially what the service will do. And it will support things like regression and classification initially. So these are typically very good things that neural networks are very good at, and generally what TensorFlow is geared towards right now. But we hopefully plan on adding different types of classification or different types of machine learning problems to the list of problems that it can support. It will be integrated with things like Cloud Data Flow and Cloud Data Lab, so you can train models by either streaming data in from Cloud Data Flow or inputting it from a batch from Cloud Data Flow, and be able to do, just like in Jupyter, you can use Cloud Data Lab to, basically Cloud Data Lab is like a Google Cloud kind of specific version of Jupyter, so it's very, very similar to Jupyter. But you can just use that to kind of train models or to play with TensorFlow. Right now it's in limited preview, but you can kind of learn more about it by going to Google cloud.google.com/nl. So like basically like what these are meant to do is allow you to kind of start to develop and test models like kind of locally using TensorFlow, but also like be able to train and run production models using things like in the cloud using cloud machine learning. And that's all I had. I think I'm right about on time.
Yeah.
But if there are any questions, I can probably take those, or I have about 10 minutes, I think.
没有什么样的问题要问Ian，因为这个是比较 overview 的部分，那有蛮多很特别的东西，就是 一直以来 Google 一直在推新的东西出来。就我刚刚中间看到有疑问，但是到现在我也忘记我要问什么。OK， 有没有任何疑问的？你可以现在先问Ian这样子。
Don't be shy.
Don't be shy. Okay. When will the TensorFlow Cloud release? I applied the trial, but
That's a good question. I don't really know, but we think in probably there will be another like kind of alpha, like with starting a new kind of alpha within a few months because they're kind of redoing some parts of it. But maybe it will be open for everybody to use like in the fall, I think. Yeah. So it's still a little bit of time. But right now, like we only there's only a few kind of researcher type of people that are using it. But we're also like making a lot of changes to it right now. So it's so yeah, we have to like kind of just make people wait for now.
Another question about one of our members asked about if I want to use Google Cloud, but I want to use some feature like CDN to hide my service IP. How will you suggest the people to do?
Hide your service IP?
Yeah, because CDN have two features about hide service IP and another is cache. Cache is already in Cloud CDN, but another, I want to hide my service IP. How can I do this?
Yeah, so like you can do that by, I mean, the server's IP itself. Well, so like if you use the load balancer in Google Cloud, like you create an IP in Google Cloud and attach it to the load balancer. So, and if you use the load balancer, that's just a single IP globally, like throughout the whole world. And so you can use that IP so like you wouldn't actually be using your own like VM's IP in your DNS. It would be like the load balancer IP.
OK。还有没有什么样的问题要请教的呢？那如果没有问题的话，我们中场先休息一下。那我们欢迎私底下来跟Ian这边跟那个嘉伟这边做一些 talk。那外面有些饮料，我们可以先休息一下。那大概10分钟、45分左右的时，我们回来这边，然后继续我们下一个课题。那就是我们 Google 也来，那我们等一下我再介绍一下。OK， 那我们先 break 一下，谢谢。谢谢。
各位饮料。